We have covered the laws, we have derived the equations, we have tackled the FRQs, but there is one specific type of problem that shows up on almost every AP Physics 1 exam and consistently trips students up, the YouTube manometer. Why is it so tricky? Because it forces you to use Pascal's law and hydrostatic pressure simultaneously while juggling multiple fluid densities. Today, in the final lecture of our Unit 8 series, I am going to show you the equal pressure line trick, a fail safe method to solve any YouTube problem, no matter how many fluids they throw at you. If you have followed the playlist this far, you are ready for this. But if the maths today feels like a leap, that's exactly what I help my students with in 1 hour private sessions. You can enroll in one-on-one classes by emailing me at yourphysicsbuddy@gmail.com. Let's master the final piece of the fluid puzzle.
Let me just give you a question. Try this question out. Let's
Okay.
see. So question is that there is a vertical U-tube.
YouTube.
Yeah, the same one which I draw in the previous page.
Okay, okay.
Of uniform inner cross-section area. Uniform inner cross-section area means that area is same throughout the U-tube. You must have seen it in chemistry lab.
No, I've not seen a YouTube.
Did you take chemistry in any of the previous
I think
classes?
I think I might have seen it, but yeah, I've taken chemistry before. But I've never seen the YouTube. No.
But it must be there in the lab. You can go and ask the lab
I don't
assistant,
think
they will
our
show you.
chemistry class last time covered density.
No, 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 it's not like density. There's the first class of chemistry in which they used to introduce
Yeah,
all
yeah, the
these.
apparatus. But
Yeah,
like
so
we were introduced to the apparatus, but we were never introduced to the YouTube in particular.
in physics lab they can show it then if it is not like that.
I don't think our physics lab has it. Our chemistry
You
lab was
can
very
ask.
expensive.
They will definitely have. You can ask.
Okay. But in chemistry class I we did like my friends and I did a lot of side experiments.
On your own.
Yeah, like when the in secret when the teacher just used to give us like random chemicals.
So nobody is there to take care of like what students are doing.
No, one time, no, the teacher is there. She said if we catch you, then you're like you'll be kicked out of class forever. But then one time she gave us like barium nitrate, and then I knew that was dangerous, so I did not do anything with that. But I think we ended up like forming chlorine gas or something like that by
Oh,
accident.
wow.
No, it was very small though. It was like
Generally, what is there is that in the lab, apart from teacher, there is an assistant as well, which
yes, no,
takes care of what
we
happens.
do have a assistant, but the assistant wasn't a grade higher than us, so then he joined as well.
Okay, now I got it.
Uh, No, the assistant doesn't care. Half of the time, the assistant is just doing their other schoolwork, and then like usually they're only there to grade stuff or like prepare the experiments. Like the necessary reactants and stuff.
Hmm, possibly. So here's the question. Read it once. Try to draw this first and use all of your knowledge and try to find out what is asked in the question.
Okay, a glycerin density 1 times 3 grams per cubic centimeter. 1 second, sir.
See, attempting any question in physics, the first step is to draw it. If you are able to draw it, then how the job is done. Because applying concept is not difficult at all.
Oh, it's Pascal's
So,
principle, rho gh, rho gh. No,
yeah, but apart from
like
Pascal's principle, also we are going to apply something else.
like okay, Pascal's principle means that like every the food the in a closed container the pressure must like like be equally distributed, right? So the pressure on the left side must equal the pressure on the right side. Left side is glycerin, the right side is oil.
Hmm.
So okay, okay, I understand it now. If okay, so if I take the pressure of glycerin, that is equal to 1.1. Is that 1.3 or 1 times 1.3? 1.3
1.3
times
gram
G
per centimeter.
times 10. So
No, no, no.
1.3.
One. Okay. If it is in, yeah, you can use one.
Oh, centimeters. Oh, it's in centimeter. I need to convert it
No, no,
now.
it's fine. You can use it as,
Okay, I'll
use
just keep
as
it
it
as
is.
that way. So
Yeah, length will be in
1.3 times.
centimeters.
Okay. So 1.3 times G times 10 is equal to the density of the oil, which is 0.8 times G times the height. So if I solve for height, height will be equal to 1.3 times G times 10 over 0.8 times G. The G's cancel out. Then you're left with 13 over 0.8. 0.8 is 8 over 10. So that's 10, 130 over 8. 130 divided by 8. It should be
See,
16.
no, 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 that's not the correct way. You need to read the question quite well first. So the question says the vertical U-tip of uniform inner cross-section area contains mercury in both its arms.
Oh, mercury.
Yeah, first it
Oh, I
has
didn't read that.
mercury.
Oh, I didn't read that.
So what does it mean? It means that initially it has mercury. So we can assume that mercury is somewhat filled till here. Now what happens is from one end you poured glycerin and from the other end you poured oil. From one end you poured glycerin,
Okay.
so you can assume this is glycerin, and from another other end it will be poured oil.
Yes.
Now this will make the difference. So
Is it the
initially
same amount?
you won't say it the same amount because the question says that we have done it till the same horizontal level. If it is at same horizontal level, so
Oh,
what should be the case? Like what are
the
the conditions when it is at same horizontal level? Think
oh.
about it. Think more about it.
Okay, okay, I see. Basically, look, the glycerin's density is much more than the oil's density, right? So that means glycerin would push on the oil more. So in order for the oil to level itself out, it would we would need more oil than we have glycerin, right, sir?
Somewhat it is right, but think about it. First of all, tell me which is more dense, glycerine or oil?
Glycerin.
So if glycerine is more dense, suppose we filled glycerine from one end, what will glycerine do?
It
It
would
will
blow
try
up.
to push, it will try to push
Yeah,
mercury upward.
mercury. Yes.
So let us see that situation. So what happens here is I'm assuming that I have poured glycerine and I have poured it till here.
Very
So what will
explosive.
so what will happen here is mercury has to rise upward. So we can assume that mercury from one end has rises till this level.
Yes.
And now from the other end, to observe the same height, we poured oil. So oil will be poured till the same level. Now think about it. So oil will be poured till this level.
Okay, sir.
So what will happen here is, so we don't know what at till what height of like how much we have poured it. So what we can do, first of all, we have to choose 2 points, and on those 2 points, we will try to we'll simply use Pascal's law at that point. What does Pascal's law says? Pascal's law says that pressure at same height is same. So what I can do is I can take this level. These are the 2 points I'm choosing. So pressure at these 2 points must be same as per Pascal's law. So finding out pressure at these 2 points is the challenge. So let me mark it as A and B.
Are the
We can
holes open,
say,
sir?
yeah, it should be open. If it is closed also, then it should be closed from both the ends. It should not be closed from one end.
Okay, so we can disregard atmospheric pressure then, right?
Yeah. So what we can do is we'll simply write from Pascal's law, pressure at point A must be equals to pressure at point B. Now, if you have to find pressure at point B, what you can do? What you can write? First of all, it is easier to find pressure for point. So tell me what we can write here. Suppose it is filled till h, till height h. Or we can also write, or something like that must be given. Let's read the question now. We haven't written what is given in the question. So a vertical U-tube of uniform cross-section area contains mercury in both of its arms. A glycerine, which is the density. So density of glycerine is given as 1.3 gram per centimeter cube. Column of length 10 centimeters. So height is given. So length up to which the glycerine is filled is 10 centimeters level. Introduced into one of its arm, oil of density 0.8 gram per centimeter cube is poured in the other arm. So density of oil is given as zero point 0.8 is poured in the other arm until the upper surface of the oil and glycerine are at the same horizontal level. So what we have given is that much information only. Only that information is given. Now what we can do? So instead of writing h here, we know that it is 10 centimeters. So we'll write 10 centimeters here.
Sir,
Now, yeah,
uh, when they say 10 centimeters, does that mean 10 centimeters of the amount poured in? Or
yeah,
like,
madam. It says glycerine column means that tube has glycerine up to length of 10 centimeters.
okay,
So
okay,
that glycerine should be 10 centimeters in length. This
okay.
is what it means. So similarly, we don't know what this is. So we can take it as h. So what this height is going to be?
It has to be the
10
same.
minus h. 10 minus h.
10 minus h.
If it is h, it is 10 minus h. So now we have few things here. So pressure at A point, what it's going to be? Pressure at A point is going to be pressure due to this column plus pressure due to this mercury column, right? Whereas pressure at B point is due to pressure because of this glycerine column.
Okay.
So we can simply now make the equation and solve it. How are we supposed to do that? We'll simply write pressure at A point is equals to pressure due to h height plus pressure due to 10 plus h height, and that whole thing is equals to pressure due to glycerine.
10 minus h. Okay.
Now you have to solve for this question.
What's PG, sir? Pressure of the
So
glycerin. Oh,
Pg pressure
glycerin.
due to
Glycerin.
glycerine is equals to
Okay.
density of glycerine, height height of the column, and G pressure due to h height. It is basically pressure due to oil, which is equals to density of oil, height, as well as gravity. Similarly, pressure due to mercury is equals to density of mercury, height, which is 10 minus h, times G. So now you can solve this equation and find out the height of the oil. So this is what we're supposed to ask, supposed to find the length of the oil column. So understanding the phenomena is important, understanding that how we are supposed to form the equation. Whenever you see such questions, you just have to figure it out. 2 points. First, you have to see that at what point we have same pressure, and the pressure will be same at those points only where the height is same. If the height is not same, we won't have same pressure, right? Then you need to figure out how many liquids we have, because sometimes different liquids will have, you can say, exert different pressure. So that is something you have to look next. These are the way. Solve for it. Solve for the equation and tell me the value of H. Here, for the glycerine, this H is going to be 10 centimeters. So put the values
Okay.
and tell me the value of height.
Okay. So let me write this down. pH plus Pg, P time minus H is equal to Pg. Then Pg is equal to rho GH, which is 1.3 times G times 10. The pressure at the height of the oil is let's see. So I do not know the pressure of the density of mercury.
Density of mercury is generally 13.6. You can
13,
also keep that in mind. Sometimes it will be given, sometimes it will not be. So try to
13.6
memorize it.
times 10 minus H, right? Okay. Okay. 10 minus H is equal to 1.3 times G times 10. Okay. Let me put this in my calculator, sir. Quick solving. Okay. For the height, sir, I got 9.6
Correct. So this is what we are supposed to
centimeters.
find it out. And again, the answer is going to be in centimeters. Sometimes it's all about the complexity of the exam. If the exam is going to be complex, such kind of questions can be asked. If it is going to be simple one, you can simply have same. See,
Okay,
there
sir.
are a lot of variations. Like there are hell lot of variations in such questions, and you can only make them questions correct if
Yes, sir.
you actually practice well or understand the concept.